can either choose to do long division first or don't do the long division first. Okay, what do I mean by that? So first, you sub 3 comma 23 over 2. I think you will get like 23 over 2 is equals to 9a plus 3b plus c over 2. So 9a plus 3b plus c equals to 23, and that is equation 1. Same thing, you can sub 2 comma 10. I forgot who do this too, but never use the minimum point already. So 10 is equals to 4a plus 2b plus c over 2 minus 1 lah. So this is the second equation. Now the third one, right, you can either do long division first, okay, or you go and differentiate with a quotient rule. I actually prefer to do long division first. Now it doesn't mean that you must always follow me or that every question will be the same. So you see ax squared plus bx plus c, right? It's inside. So below is x minus 1. Okay, multiply by what? Ax, right or not? So I will have ax squared minus ax. Put a minus and a bracket. This part, be very careful. This will be called b plus a plus c. Very good. B plus ax plus c. So to eliminate the b plus ax, right, I must multiply with another b plus a. Because this times x, right, will become b plus a x. Okay, minus open bracket b plus a. You draw a line, you put a minus and a bracket on the outside. Okay, this will become c plus b plus a. So this is my remainder. Which means that, okay, so now I know that my y is equals to ax plus b plus a plus remainder c plus b plus a over x minus 1. It's easier to do this differentiation. Why? Because that one, right, you have a quotient rule and a, b, c are unknown. Okay, this one is easy to do a differentiation because dy dx, differentiate ax is just a, differentiate this become nothing. You all must be to be good at H2 math, right? Or rather to be decent to pass at H2 math. This kind, right? X minus 1 power bring up power negative 1, right? When you differentiate power negative 1, you must be so smooth to know that this one is negative c plus b plus a over x minus 1 square. Okay? If you cannot do because never do enough times of x minus 1 to the power negative 1, differentiate this power bring down, power decrease by 1, power negative 2 bring down. Understand or not? Okay? So now you sub in when x equals to 2, dy dx equals to 0. You will get b plus c equals to 0, I think. 2. Yeah, b plus c equals to 0. All you need to do is to sub these three things into your calculator. Okay? You are going to get a equals to 3, b equals to negative 2, c equals to 2. You do key again?
Yeah, key b minus c, not minus b minus c.
No wonder. Yeah. Okay. Usually it will be all constant. So now you know that this is y equals to, so you put in all the values, 3x b plus a plus 1 plus 3 over x minus 1. Okay. So at this point of time, you all should already know that you will have two asymptote. One is an oblique asymptote at okay, and then you have this, which is the minimum point that they tell you is 2 comma 10, and then your turning point just happens to be at the y-intercept there. This is negative 2. Label this y equals to 3x plus 1, x equals to 1, as well as label your graph y equals to 3x plus 1 plus 3 over x minus 1. Okay, look here, look here, look here, look here, look here, guys, you're not looking here anymore. Okay, if the question asks, what are the values of y that the graph cannot take? Very good. That graph cannot take is negative 2 to? So the values of y means we look at the x-axis or y-axis. Y-axis, right? Can you see the graph is non-existent from here to here? What is the value here? 10. What is the value here? Negative 2. So the y is in between negative 2 to 10, not inclusive. Okay? Understand? But of course, this is not the question. They ask you to draw this. Now, next part of the question is
Is it like more than or equals to, or is it just more than?
more than. Because when it's equals to, there's a point there, right? Okay? Okay? So next part, right? The question talks about x square over k square minus y minus 1 square over m square equals to 1. The question already very nice because they never ask you to do completing the square or anything like that, right? And they already put it nicely here for you already. You need to identify that this is a east-west hyperbola. At the center, 0, 1. Can see it's 0, 1. Okay. Now, after you identify the center, right, you need to find the asymptote. The asymptote is y minus 1 over m square equals to x square over k square. Imagine the 1 to become a 0. Square root both sides, y minus 1 over m equals to plus minus x over k. Y minus 1 equals to plus minus mx over k. Y equals to plus minus mx over k plus 1. Okay? So now the question tells you to add in a hyperbola with the center at 0, 1. Where is 0, 1? Listen here very carefully about the hyperbola. Okay? 0, 1 is here. Okay? So there is a hyperbola that is going to be like that. And for the purpose of the question, I'm going to draw the same gradient as this way. Okay? Now there's an east-west hyperbola that is here and here. Okay? This part can understand? The question says that I do not want it to intersect the C. Okay? I do not want it to intersect the C. This is the point where I'm going to bring out my ruler. Okay? Now, for the first part, always draw your asymptote, right, to be together with the oblique asymptote. It will always be related to the oblique asymptote, understand or not? So now, can you see the oblique asymptote? What is the gradient on the oblique asymptote? 3, right? 3, right? If I get steeper, can you see if my oblique asymptote gets steeper? My hyperbola will become like that, right? Does it cut? Can you see? Does it cut or not? Does it cut? Does it cut? Yes, right? So in order for the hyperbola not to cut the graph, the gradient of the hyperbola must be more steep or less steep? Less steep. Man, it must go like that, right or not? Understand? Now the gradient of the hyperbola is the same as the oblique asymptote, which is 3, right? Yeah, I must get less steep to be here. Understand? Until where? The gradient of hyperbola can be like that, but the hyperbola cannot be. Can the gradient of hyperbola be 0? No, because if it's 0, then the hyperbola will not exist. Okay? So that's why the answer for this should be, okay, you have to identify that m over k equals to gradient of asymptote of hyperbola. Okay? To not intersect C, my m over k must be lesser than. Now, when it's equals to 3, does it intersect or not? Does it intersect? Yes, right. So it can be equals to 3. But it must be strictly greater than. Can the gradient be 0? No, strictly greater than 0. And that is the answer. Now, Ryan and Janessa wrote okay? This one, right? You roughly have some idea, but maybe it's because I wrote in the book. Firstly, if you do this, right, does it encompasses 0? Yes, right? Does it include 0? Minus 3 to 3, does it include 0? Yeah. But can the gradient of a hyperbola be 0? Cannot, right? Yeah. So that's why it cannot be 0. Next is, can you see there's a plus minus here? Can you see there's a plus minus here? Yeah. So the plus minus already encompasses the negative part already. That's why only this part is the answer. Because you see, the plus minus here already encompasses here. That means if your m over k could, if anything from 0 to negative to 3, right, it could be because the asymptote is m over kx plus 1. It could also be negative m over kx plus 1. Understand? Can you see if the m over k is this one? This part is 3, right? Then the negative 3 is it's already taking care of the other part already. So we only need to say that it's from 0 to 3. Always associate the gradient of the hyperbola with the oblique asymptote. Okay, always. So this is not correct. This is the correct one. Associate the gradient of the hyperbola with the gradient of the asymptote. Okay, and lastly, in the case where a equals to this, okay, so now look here. There are two ways to do this. So I have y equals to ax squared is inside my H2 summary pack. These things I want to say is all inside my H2 summary pack. Okay, I'll show you two ways, right? I show you two ways. So this is ax plus b plus a. Okay, they say that a equals to -1, b equals to -1. B plus a plus c plus b plus a over x minus 1. Okay? Can? For the case of this, find the range of c to have no stationary point. When you see the word no stationary point, what must come to your mind? 1. dy dx cannot be equals to 0. Oh no, sorry, no. Actually, that's the only one. Dy dx equals to 0 have no solution. Have no roots. When you see no roots, no solution, what other concept must you think of? Discriminant. You must think of discriminant. Okay? So it depends on whether you have used this to do the quotient rule at the start or not. If you have used this to do the quotient rule at the start, then you will be able to use discriminant, okay, less than 0. Like in this case, for example, dy dx is equals to, okay, I have to write the values. I have to write the values inside first. So this is equals to negative x squared minus x plus c over x minus 1. dy dx is equals to x minus 1, differentiate this, minus 2x minus 1 minus x squared minus x plus c, okay, times 1 over x minus 1. So if you can make the bottom nice, right, the bottom will become a quadratic. Okay, this will be negative 2x squared plus 2x minus x plus 1 plus x squared plus x minus c. Yeah, doesn't matter the bottom. Okay, so over here, this will become minus x squared plus 2x plus 1 minus c over x minus 1 squared. So this is your dy dx, right? This is your dy dx. Okay, so in order for dy dx equals to 0 to have no solution, yeah, just take this, because to be equals to 0, it means my numerator must be 0, right? Take this and do b squared minus 4ac must be smaller than 0. And understand why? Okay, so you just take b squared minus 4ac less than 0, and then you will get the range already. Okay? Okay. Or if you have already done it in this way, okay, it will probably be about the same thing. Yeah, but the other one, right, is more elegant in the way that, okay, so look here, y equals to minus x minus 2 plus c minus 2 over x minus 1. Okay, so look here. This one is a bit, dy dx equals to minus 1 minus c minus 2 over x minus 1 square. Okay? Can? So your workings is like, okay, so this is equals to 0, right? Minus 1 equals to C minus 2 over, this one is actually easier to get. This part can understand? If I have stationary point, can you see? Okay? Can? So for no stationary point, okay, maybe you can cross multiply first. X minus 1 square equals to C minus 2 over negative 1. Can you see I just go up and then go down, and the negative 1 go down. For no stationary point, what is the crucial part about this?
It's x minus 1 square is also
Correct. Can you see this is a square? If this guy is positive, can I square root? Can I square root? If this guy is positive, can I square root? Yeah, if it's positive, I can square root, right? But do I want to be able to square root? No, right? Yeah. So for no stationary point means I don't want it to have any roots, right? Now, can you see this x minus square equals to this? Minus c plus 2 must be less than 0. This part, understand why? Because you cannot square root a negative value. This part easier to get. This will satisfy the answer. C must be greater than 2. That's the answer. If you do b square minus 4ac, you will also get c greater than 2. Okay? This part is more elegant in the way that you understand the gist about a square value. That you want to square root, you can only square root something that is positive.
So this one is because it's no stationary point, so you make sure that the equation is not
Doesn't work. Yeah. Yes.
So then you get 4 minus c plus 2 to be negative.
Correct.